In this video, we're going to solve problem 4 of the power screw series. Find the power required to drive a 1.5-inch power screw having double square threads. So we have square threads and it's double. That means that the lead is twice the pitch with a pitch of 1/4 of an inch. The nut is to move at a velocity of 2 inches per second. So we have the velocity and we have the lead. We can find the RPM. And move a load of 2.2 kip. So that means that we are lifting a load, and that's the load that we can move. The frictional coefficients are 0.1 and 0.15 for the thread and collar respectively. The frictional diameter of the collar is 2.25, and our job is to find the power. We know power is torque and RPM. We don't have either of them, but we have values that we can find. To find the power for the torque, we can find it based on thread properties and the resisting force, the force that we use to lift it up. That's the force that is given to us here. And for the RPM, we can find it based on the velocity that we have and the lead. So let's write the known values. The lead is twice the pitch, simply because the problem tells us it's a double thread or double start thread, and the pitch is given to us. We have the equation for power. We need to, whether it's SI or British system, so this is the imperial system. That's the equation that we're going to use. In this is RPM, this is pound/4 inch, so we need to know the correct units for this case. The velocity is 2 inches per second. If you want to find the RPM, that would be the velocity divided by the lead. So I change inch per second to minute. So that second would go away, and then revolution per inch. The inch would go away here, cross out. So at the end, I will have revolution per minute, or RPM. That's the RPM that I found based on the lead and the velocity. So I found one of the unknown. I need to find the torque. If I have the clamping force, I have the property of my thread is a square thread. I can find dm. Dm would be simply the major diameter minus half of pitch. The rest of the values are given to me, like the coefficients of frictions, like the collar diameter, like the lead, and I can find the torque. Now that I have the torque and RPM, I can find the horsepower. So that's the horsepower that I need to create this clamping force based on the RPM that I have. So to have that velocity and to create this clamping force, this is the horsepower that I need.